Hey everyone, I am here in Berlin to deliver a talk at FICC 2025 on AI alignment. This is the paper that I wrote last year with Lara and I. So I'm going to present that in Berlin. I'm going to give you a run through of the talk. Now, I will warn you in advance that scientific papers are quite short in their talks. It's usually a 10-minute talk with 2 minutes for questions. So I'm going to go ahead and do that, and let's get started. Okay, welcome to the elephant in the room. This is a paper on AI alignment. And so let's talk about the AI alignment problem. So the fundamental problem of AI alignment is trying to ensure positive outcomes for humanity in our interaction with AI. Now, here we have a picture of the last time that the human species faced the alignment problem. In among these skulls are 4 different types of human beings. There were the one that descended to us today, and also Homo neanderthalis, Neanderthals, the Denisovans, and finally Homo florensis. And there were probably others as well. So the Denisovans and Neanderthals did not survive to the modern day, but they did pass on some of their genes through interbreeding. Homo florensis died out completely, and obviously we survived. So that leaves 4 different outcomes: positive, negative, and let's call it a third way or mixed. So in our interactions with AI, we are now essentially facing the first time in 10,000 years that the human species has had to deal with non-human cognitive capable entities. And we would like to ensure positive outcomes. How do we do that? There are 2 camps. One, which is currently the mainstream camp, is the control-based camp, or the game theory camp. And you will hear some of these words, the instrumental convergence, terminal race condition. That is the camp used by OpenAI with its reinforcement learning through human feedback. The alternative camp, which is based on social science, is less based on controlling models and more based on assuring our relationship that's positive. And so that is the system used by Anthropic with its Claude models, which not only have a kind of constitutional AI as their framing, they use a constitution to set the values of the model. They actually use the UN Charter of Human Rights as part of that constitution. So 2 different camps. Now I'm going to quickly introduce the team. This is myself. This is Lara Scheibling, my co-author. And it's important to note that we're not academics. We're actually work in industry. And so we wanted to kind of bring more advocacy to the social sciences side. So how do we do that? And why do we want to do it? Well, here we have 4 different professions shown: a parent, a priest, a psychologist, and a prison warden. And all of them have to deal with complex real-world problems with cognitively capable entities that don't necessarily share their same values or goals, and nonetheless, they're all able to achieve results. And so the idea is that in the social sciences, we have a lot of material on conflict, and the idea is we would like to bring some of that over to AI alignments. However, we lack a theoretical framework for doing that. That doesn't mean that people aren't doing it. Anthropic, for example, is doing some parts of it, but we would like an overall theoretical framework on how to bring social sciences into AI alignments. And so we made one. And so our proposal was this framework, which has 3 pillars. They are defining a subject North Star, and we'll talk about that more in a minute; taking media seriously as a library of archetypes; and finally, the importance of avoiding groupthink in team composition and why diverse teams can help with that. So what can you do with such a framework? Well, you could use it to align models, but if you have models that are already aligned, you could evaluate their alignment to see how good it is. And then finally, if you're a regulator, this gives you a toolkit that you can use to try to bring in some techniques for social sciences into AI regulation. Okay. So let's start with the North Star. So the North Star, or the highest goal, was to have a subject-subject alignment framework. What does that mean? Well, if we look at, for example, negotiating theory, there are win-lose versus win-win negotiations. So in a win-lose negotiation, that is what we call a subject-object framework. That means that I matter and you do not matter. I'm trying to maximize my outcomes and I'm willing to minimize your outcomes. Now, in a subject-subject framework, all of the participants are subjects, which is to say that their needs and values are all taken seriously. So that is a win-win negotiating framework. So we believe it is critical for alignment frameworks to choose subject-subject frameworks. Why? Well, because AI is rapidly increasing, actually exponentially, in capabilities, and it is likely that it will, if it hasn't already, soon exceed human capabilities. And what that means is it's very difficult to contain entities that can outthink you. So if you use a subject-subject framing, for example, parents often teach their children values, and even though the children are intended to become more capable and hopefully eventually do become more capable than the parents, those values are sticky and persist. That is the sort of framework that we think is crucial. Now, the second pillar is using media archetypes as thought experiments, taking them seriously as scenarios. So why would you do that? Well, two different reasons. So the first pertains to the compression. So if I show you these three different movie posters from the movies Her, iRobot, and Terminator, they represent three different AI alignment scenarios. Her is positive, Terminator is obviously negative, and then iRobot is a positive scenario where a mixed team of humans and AI together ends up containing a wayward AI. So just by showing you the movie posters, if you've seen those movies, you've got a very well fleshed out idea of the scenario in your head. So they're very highly effective at data compression. However, even more importantly, they're all popular. And the importance of popularity is that it counts as a sort of upvote. In the case of these films, millions and potentially billions of people have actually viewed them positively and potentially paid money to see them. So we know from swarm theory and aggregate intelligence theory that this method of aggregating together answers gets better answers, that there's value in them. So in AI alignment, we call that ensembles. And if you make an ensemble of dumber models, you can get an answer equivalent to that of a more intelligent model by voting. So it is a form of crowdsourcing intelligence and actually works. So scenarios that are popular are scenarios that are highly likely to be important. And this is actually taken seriously in futurism. There's a technique called science fiction prototyping that does exactly this. So our third pillar relates to team composition, and this is where the paper takes its name from. It comes from the metaphor of the elephant and the explorers, where they can only perceive a part of the elephant, and so they need to synthesize together their information to produce a coherent description. So we think that will likely happen with AI alignment scenarios for many reasons. Number one being a subject-subject framework requires exploration inherently. You need to figure out what the needs, values of the other party are. But also there are many unknowns and a lot of conflict in this terrain. There are a lot of actors or different models. There's NGOs, governments, people. So the idea was that reducing groupthink would be particularly important in AI alignment. And a technique for doing that would be to pull in different points of view. So we suggested recruiting across conflict-rich social science professions some team members to kind of reduce groupthink and ideally produce a more well-rounded point of view. There are other factors there. I won't go through all of them, but one of them was to point out that we can expect that alignment teams themselves will use AI tools, leading to then kind of human AI alignment hybrid teams, similar to in the story of iRobot again. Okay, and finally, I would like to show you the results, but this is a conceptual paper, and so we don't have any. However, we did lay out some methods by which one could measure results and compare if this framework produces better or worse results. So the first, which is valuable because it can be done through natural experiments, is simply comparing the different alignment systems for existing models in the market and their results as we start to get research now on models evasion or dissembling or things like that. Those papers can be classified by whether the model is value-based or a control-based system, and we can get some interesting results out of that. Another was that we could arbitrarily define good versus bad behavior. And we're starting to see this, for example, with some papers defining power seeking as bad, and then trying to rate whether the different types of models and their alignment systems do better or worse against that. And then finally, what I think is probably the most valuable one, and one that's actually quite a straightforward experiment, is that we have human alignment tests. The moral reasoning test, for example, is a human-to-human alignment test. And you can actually apply that to AI models. There's no reason why people can't do that today. And so that is a good area of research. Okay, that's it. I'm going to throw up my contact information and we will take some questions. So that is the talk. Let me know what you think in the comments. Take care. Bye.